Hello everyone, welcome to Vishesh Educational Videos. So in this video, I'm explaining the concept of covariance and correlation. So if you're not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon. So let me begin the explanation of covariance and correlation concept. Now, both covariance and correlation are two mathematical concepts used in statistics, right? Both terms, both covariance and correlation, used to describe how two variables, right, are related to each other. I'm making it very simple. I don't want to confuse you guys. So covariance and correlation, both of them, they are going to tell about, or they are going to describe about any two variables, that how much they are related to each other. So for example, covariance is a measure of how two variables change together. That means covariance it tells about how two variables are different to each other. For example, if I consider the two variables as 2 and 2, that means my two variables are same. First variable is also 2, second variable is also 2. So how much they are different means nothing. They are not at all different, because my two variables are one and the same. Suppose if my two variables are 5 and 8, 5 is different, 8 is also different. So covariance tells that how much both 5 and 8 are different to each other. The difference, the change between the variables, how much they are changed, that means how much they are different. For example, if you calculate the covariance, I will explain with an example, between 5 and 8. So the value may be 3.5, 4.5, like that. So 5 and 8 are different. It will give some value. They are different. The value will be 3.5. 3.5 times they are different, like that, right? So don't get confused, guys. So covariance measure between the difference between two variables. In the same way, correlation is a measure of how two variables are related to each other. For example, I will consider my variables as two variables as 3 and 3. First variable is also 3, second variable is also 3. How much they are related to each other means 100% they are related to each other, because the two variables are same. For example, if I consider any two different variables, how much they are related means it will, if you calculate that, it will give some value, that is this much, these two variables are this much related, like that. Getting my point? So covariance is going to tell how much the two variables are different. Correlation is going to tell how much the two variables are same. That means how much they are related to each other, right? And one more thing, covariance indicates the direction of the linear relationship between variables, right? So it is going to identify the direction of linear relationship. I'm going to explain with an example. And correlation measures both the strength and the direction of the linear relationship. Covariance only tells about the direction of the linear relationship, but correlation tells about the strength also, along with the direction of the linear relationship, right? And correlations values are standardized, but covariance values are not standardized. So these are the differences between correlation and covariance. If I explain with an example, so you can easily understand the concept, right? Now, so I already told you, right? Covariance signifies the direction of the linear relationship between the two variables, right? By direction, we mean that if the variables are directly proportional or inversely proportional to each other. If you consider any two variables, covariance tells the difference. Either they are directly proportional to each other or inversely proportional to each other. That means increasing the value of one variable might have positive or negative impact on the value of the other variable. That means impact means what? Positive impact or negative impact means difference, how much they are it is impacting positively, or how much it is impacting negatively. that means if you change one variable, it will affect other variable also. That's why covariance is mainly about the difference, how much it's going to affect the other variable if you change one variable, right. And the value of the covariance can be any number between two opposite infinities. I told you. So how much they are different, how much they are different means you can measure the difference right, between measure the difference using some using some value. That value is nothing but a number. You are going to get some number, so that number can range between the two opposite infinities, right. And covariance only measures how two variables change together. I already told you, right, not the dependency of one variable on the other one. I'm not going to calculate any dependency, how one variable is dependent on the other variable. No, in covariance I'm just calculating the difference between the two variables, right. So I don't want to confuse you guys. To calculate the covariance, I have a formula. We should apply that formula. Based on that formula, we are going to get the value that how much two variables are different. Okay. This is the formula for calculating the covariance of two variables. My two variables are x and y. So I am calculating with a summation. So you can see here. So the upper and lower limits for the covariance depends on the variances of the variables involved, right. Here I am considering, right, xi and yi, and I am subtracting both xi and yi with x bar and y bar, and I am dividing with the n. You will understand what is n, all those things with in the example. So you can see here covariance is telling based on that. For example, is explaining how your variables are grouped here. For example, if covariance value is lesser than 0, you can see here my variables will be grouped like this. Suppose it's equal to 0, you can see here, right, my variables can be grouped like this. Suppose my value is greater than 0, that value, whatever the value I am going to get, that value of covariance is greater than 0, my variables can be grouped like this. So you can see here, so groupings are different based on whatever the value I am going to get for covariance, right guys. Now, so I am going to explain with a example here. So you know that this is the formula, summation of, right, and these are the values. So x variable, y variable values. So I'm considering four values here, and I'm going to find out, right, what is the difference between these variables, how much they are different, right. So it's very simple. So first step is what here, so calculate the mean of x and y. We have to calculate the mean value. To calculate the mean value, we have to add all the values and divided by the number of values. So n is the number of values. What is the value there? The value will be 4. The value will be 4, right? Getting my point? So see here, I will add all the values, So I will add all the values. To calculate the mean, I have to add all the values divided by the number of values. 10 plus 12 plus 14 plus 8. See, you can see here 10 plus 14 plus, right, 8 divided by 4. So I will get the value 11. So next I have to calculate mean of y. I will add, right, 40 plus 48 plus 56 plus 32. You can see here, and you have to divide that value with the value n. What is the n value? 4. So you are going to get the mean value 44. So what I did now, I calculated the mean value for x and I calculated the mean value for y. So mean value of x is 11 and the mean value of y is 44. Very simple, right? You have to add all the values divided by the number of values, that is n. Now substitute the values in the formula. I'm going to substitute the values in the formula. Before that I have to find out xi minus x bar. So xi, what is the first value of x here? 10. 10 minus 11. 11, x bar means what? Mean value. What is the mean value here? 11. So if I will subtract the x value with the mean value, 10 minus 11 is minus 1. I will repeat the same process for remaining values of x, like 12 minus 11, 12 minus 11 is 1, and again same, 14 minus 11 is 3, 8 minus 11 is minus 3. Getting my point, guys? Very simple, you can see. In the same way I will repeat the same value for yi minus y bar. So y, I am dividing all the values of y with the mean value. So my mean value is what? 44. You know that mean value of y is 44. I will do that. 40 minus 44, 48 minus 44, 56 minus 44, 32 minus 44. I am going to get these values. Minus 4, 4, 12, 12. And for x bar, xi minus x bar, what is the value? Minus 1, 1, 3, minus 3. Now I calculated the values and I am going to substitute these values in the formula. You can see here, what is xi minus x bar? What is the first value here? Minus 1 and minus 4. First substitution. Next 1, 4. Next 3, 12. Next minus 3, 12. Getting my point, guys? I'm just substituting the values. It's very simple, you can understand that. Suppose if you have any doubts, please post your doubts in the comment section, right? So I substituted all the values of xi minus x bar and yi minus y bar. I am multiplying both xi minus x bar into yi minus y bar, and I am dividing those values with n. N is that is nothing but number of values. What is the number of values I am considering? 4. You know that x value is also, number of values of x is 4, y is also 4. That's why the value is 4. If you calculate this, you are going to get the value 8 divided by 2. 8 divided by 2. So final covariance value what you are going to get is 4. You can calculate it very easy, right? You know that, right? So covariance of x comma y will be, that is 8 divided by 2. So 2 4s are 8. So that is the value of covariance is 4. That means these values of x and y, that is 10, 12, 14, 8 and 40, 48, 56, 32, how much they are different means they are different they are different by the value 4, right? So this is the difference value, that is the two variables are different this much. What is the value you get? You got 4. So I already told you, value ranges from two opposite sides of infinities. From minus to plus, you can get any value. Hope you are understanding the concept. Suppose if you have any doubts, please post your doubts in the comment section, right guys? So next, correlation. It's exactly opposite to the covariance. Covariance is going to measure the difference between two variables, but correlation, as the name suggests, relation, it's going to tell how much the two variables are related to each other. Getting my point, guys? So correlation analysis is a method of statistical evaluation used to study the strength of a relationship between two numerically measured continuous variables. I don't want to confuse you guys. In simple words, it is going to measure the relationship between the two variables. That means how much they are same, actually, how much they are related to each other, right? And it's not only going to tell about the direction, it's also going to tell about how strong the relationship is. That means how the two variables are related to each other, right? So that's why correlation is standardized. We can say that the correlation values have standardized notions, but covariance values are not standardized and cannot be used to compare how strong or weak the relationship is, right guys? So I can't tell how strong or weak the relationship is if we in the covariance, because the values are not standardized. That means values can range from infinity, minus infinity to plus infinity. I told you opposite ends, but here values are standardized in correlation. That's why right, I can tell how much strong or weak they are. So what is the values here? -1 to +1. So I am standardizing the values. Whatever the value you are going to get in correlation should be between this range. I am standardizing it. But in covariance, it's not the case. I am not standardizing the value because it ranges from infinity, minus infinity to plus infinity. But here I am specifying some range here. The range to measure the correlation is -1 to +1. So that's why here my values are standardized. That's why I can calculate how how the relationship between my two variables is strong. How means how, whether it is strong or weak, like that. Next, right? So I don't want to confuse you guys. I directly move to the example. Right, correlation formula is, this is simple. Correlation, to find out the correlation, first we have to find out the covariance. See, right? So once I find out the covariance, I can divide the value by right, sigma x into sigma y. So see here, what is this means? This is standard deviation. Sigma x is a standard deviation of x, sigma y is a, right, sigma y is a standard deviation of y, and this is the variance. It is very simple. And see here, the correlation coefficient is a dimensionless metric and its value ranges from -1 to 1. I already told you value -1 to 1. I already told you that. The closer is +1 or -1, the more closely the two variables are related. That means if you consider -1 also or +1 also, it should, whatever the value you are going to get, that should be close to these two values. So I can tell that this much variables are related to each other. If there is no, for example, if there is no relationship between the two variables, so certainly the value will be 0. If value is 0, I can tell that there is no relationship between the two variables. If there is a relationship, the value should be between +1 to -1. However, if it's 0, right, right, that is, however it's 0, we can tell that no, there is no relationship between the two variables. When the correlation coefficient is positive, positive means what? If one variable increases, I can tell that other variable also increases, right? So if the correlation coefficient is negative, the changes in the two variables are in opposite direction. Getting my point? If it's positive, I can tell that if it increases, one variable, if the value of one variable increases, others also increases. But if it's negative, right, the changes in the variables are exactly opposite. If it's increasing, then the other variable will decrease. If it's decreasing, then the other variable will increase. So exactly opposite if it's negative. Okay. Now I will move to the example. Same values I am considering here: 10, 12, 14, 8, 40, 48, 56, 32. So first what I have to calculate, covariance I have to calculate. So that's why I am calculating x minus x bar. You know the formula, right? I already explained it. yi minus y bar. So again I have to calculate the mean. So what is the mean of this? 11. Mean value of x is 11. Mean value of y is 44. You already know this, guys, right? I don't want to confuse you guys. So what is the covariance value? Same things I am repeating here. What is the covariance value? You are going to get 4. Okay, 4. The covariance of the above data is 4. Now I have to substitute this value 4 here. So before that I have to find out the standard deviation of x and y. So this is the formula for the standard deviation. So see here, how I will find out the deviation. Once I find out the deviation, I can substitute the deviation and covariance both in the formula of correlation. So first I find out the value of covariance. Now I have to find out the standard deviation. Right? Getting my point, guys? Okay. See, standard deviation. So I'm calculating the standard deviation. To calculate the standard deviation, see 10, I'm considering the value of x. What are the values of x? These things. Okay, I'm subtracting with the mean value. What is the mean value of x? 11. See, 10 minus 11, 12 minus 11, 14 minus 11, 8 minus 11. Don't get confused. I took these values and I subtracted these values with the mean value, that is 11. So what are my values? Minus 1, 1, 3, minus 3. But now I have to find out the square root, guys. Okay, square root, because you know that here we have a square root. So what are the square roots means? 1199. You know that 1 into 1 is 1, 1 into 1 is 1, 3 into 3 is 9, minus 3 into minus 3 is again minus into minus is plus. So the value is 9. So I found out the square roots. Now see, find the mean deviation. I already found out. Same sum of the squares is what? 20. If you find out the sum of the squares, why you have to find out the sum of the squares? Summation, that's why. So sum of the square is 20. I found out 1 plus 1 plus 9 plus 9. Right? Getting my point. Find the variance. Divide the sum of square with n minus 1. Why? Sum of the square is 20. N minus 1 is 4 minus 1 is what? 3. So 20 divided by 3 is what? 6.6. Don't get confused, guys. Here n minus 1 is what? 4 minus 1, 3. So this value is what? Sum of square root is what? 20. Don't get confused. First I found out the square root. First I find out the x minus x bar. Next I find out the square roots, that this one. Next I have to add this, right? 20 divided by 3 is 6.6. Now what is the square root of the 6.6? Now I find out the value, summation of x minus x bar divided by n minus 1. And again I am to square root that value, that is 2.581. Therefore the standard deviation of x is 2.581. Getting my point? Don't get confused, guys. Please don't get confused. In the same way, I have to find out the standard deviation of y. Instead of x minus x bar, I have to substitute y minus y bar divided by n minus 1. That is x minus x bar whole square divided by n minus 1. Same process will be repeated for the standard deviation of y. Getting my point, guys? So don't get confused. First what I did, I found out the covariance. Right? I found out the right. Sorry. Wait. First covariance value I found out. Yes, 4. It is 4. Now I have to find out the standard deviation of x and standard deviation of y. To find out the standard deviation of x, I used a formula: summation of x minus x bar of whole square divided by n minus 1 overall square root. Okay. Now I have to substitute the values. So to substitute, first of all I have to find out x minus x bar. I find out the values here, x minus x bar values. Now I have to whole square. Whole square means what? Minus 1 into 1, minus 1 into 1, 3 into 3, 9 into 9. 3 into 3. Don't get confused, guys. Whole square means what? Minus 1 into 1, 1 into 1, 3 into 3, minus 3 into 3. So what are the values I got? 1199. But we should add these values and we should find out the square root of these values. So I added these values. The value is 20. Now I am going to find out the n minus 1. What is the value of n minus 1? 4 minus 1, 3. Now I will divide 20 by 3. You know that n minus 1 is 3. and the value of summation of x minus x bar of whole square is what? 20. So 20 divided by 3 is 6.6. And what is the square root of 6.6? The value is 2.581. Don't get confused. Suppose if you have any doubts, please post your doubts in the comment section. Now I found out the value of standard deviation of x, but I have to find out the standard deviation of y. For that, the formula will change. Instead of x minus x bar, you have to substitute y minus y bar whole square. So when you apply that, you are going to get a standard deviation of y as 10.29. Now I have all the values. Standard deviation of x, that is 2.581, and standard deviation of y is 10.29, and the covariance value is 4. So now I can substitute this value. See, 4 covariance I substituted 4 divided by, what is the standard deviation of x? 2.581 into what is the standard deviation of y? Into 10.29. Getting my point? So standard deviation of x is 2.581, standard deviation of y is 10.29, and the variance value is 4. So 4 divided by 2.581 into 10.29. So if you calculate that value, calculate that final value will be 0.15065. So that is the final value of correlation. So how much they are related? How much these variables are related? How much these variables x and y are related means they are related by 0.15065 times. Getting my point? So if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.